Hi guys, it's Mr. Rose here coming to you from your computer screen. Just a quick 10-minute video showing you guys how to do two-part calculations using the mole tool chest that we've got so far and what we've done so far this year. So I hope you don't find it too complicated. It's just a couple of simple steps, practicing already things that we've done. Okay. So in our tool chest so far this year, we've got the first formula we use right here is the number of moles equal to the number of atoms, molecules, formula units, something that you want to be able to solve for to calculate the number of moles of it, whatever that could be. That's the capital N. This Na right here is Avogadro's number, so that's 6.02 times 10 to the 23 of whatever it is that you want to calculate per mole. So for those of you who need a little extra help with rearranging the formula, the triangle's here. The second formula that we did this year is the number of moles is equal to the mass of a given substance in grams divided by the molar mass of that given substance in grams per mole. Okay, so this number of moles is equal to mass in grams divided by the molar mass in grams per mole. And again, the same thing, triangles here available for you if you need it. All of this information is also going to be on each and every slide as we go through the following examples. So there's three examples. The first one right here is how many molecules are in 26.9 grams of water. Okay, so just as a little bit of a heads up before we go to do this problem, we can tell based on the information that we've got there that I know what the little m is going to be in this formula because we're told we got 26.9 grams of water. I also know the chemical formula for water, H2O. So because I know it has two hydrogens and one oxygen, I can figure out exactly what the molar mass of water is going to be. Okay? So in this formula right here, the one I'm circling right now with the laser pointer, I already know two of the three unknowns. So because I know two of those three unknowns, I can solve for this little n. Okay? The question asks me to solve for the number of molecules of something, so I know that the last thing I'm going to have to find is this. But I can't get down to that formula until I know this variable and this variable. I know this one, so what I must solve for must be the number of moles first. So when in doubt with these formulas, and generally all the time with these formulas, the first thing you need to do all the time is find moles using whichever formula you have two of the three variables for, which in this case is the top one, the molar mass formula. Okay. So what information are we given? Well, we're given the mass in grams of water, 26.9 grams. We know based on the periodic table information that we've got for each atomic mass unit that the molar mass for water will be 18.02 grams per mole. We've got 1.01 for each hydrogen. There's two of those, so that makes 2.02. And then water 16, so 16 plus 2.02 makes 18.02 grams per mole. I also know Avogadro's number all the time. Okay, that never ever changes. The only thing that changes is what we're trying to count the number of moles for. So Na in this case is 6.02 times 10 to the 23 molecules per mole. So ultimately, the problem asks me how many molecules are in that mass amount of water. So I'm trying to find capital N. Okay, that's the end goal for this particular calculation. So step one in the calculation is always going to be write your formula down. So the formula that we need first is going to be the number of moles is equal to mass divided by molar mass. And we know based on some of our given information that we have 26.9 grams of water, and we know that the molar mass of water is 18.02 grams per mole. So using that calculation, I can figure out the number of moles, which is 1.49 moles of H2O, or water. Now notice that my answer in that case only has three significant digits. The reason why it has three significant digits is the two numbers I used to calculate it. The lowest number of significant digits is 26.9, and that was the mass amount. So now that I know the number of moles, okay, using this formula, I can take the number of moles and use that, plug it in down here, along with Avogadro's number to solve for this capital N. So the capital N in this case being the number of molecules. So if I cover that off, I'm left with moles times Avogadro's number, which is exactly what I do right here. So molecules is equal to moles times Avogadro's number. So I got 1.49 moles times 6.02 times 10 to the 23 molecules per mole. The moles will cancel, and I'll be left with 8.97 times 10 to the 23 molecules. So that's your final answer for that one. Now, some of you guys may experience a little bit of discrepancy with your answer from mine, maybe off a decimal place or a couple decimal places. You might get 8.99 times 10 to the 23. If you do, that's because you either A, use 6.022, or you didn't minimize to 3 significant digits in your initial mole calculation. But you should be able to get it to try to match it with 8.97 times 10 to the 23 molecules. So that's problem type number 1. Problem number 2 is basically a reiteration of that one. The only just little extra complication that I've got here is I've given you glucose instead of something simpler as water. So this one asks us how many molecules are in 4.78 grams of glucose. Again, we know our mass, and the chemical formula for glucose is C6H12O6. So based on that, we can calculate the molar mass. Now, so my mass being 4.78 grams, the molar mass of glucose, once I calculate it all out, is 1.80 times 18, or 1.80 decimal 18, grams per mole. And using that formula, I can figure out the number of moles. I also know Avogadro's number all the time. So that's 6.02 times 10 to the 23 molecules per mole. And just as the last question was, we're still looking for the number of molecules, so this capital N right here. So that the end goal is going to be to find that N. So we start off with our initial formula the same as last time. So I've got the number of moles is equal to the mass divided by the molar mass. In this instance, our mass was 4.78 grams of glucose divided by 180.18 grams per mole of glucose. And that works out to be 0.0265 moles of glucose. Now, some of you guys might get a little bit, you should get that exactly based on your significant digits. If you want to have it in scientific notation, it would be 2.65 times 10 to the negative 2. But either way is fine. So that's how many moles of glucose we've got in that example. Okay. So now that we know our moles of glucose from this formula, we can take that in and put it down in right here, and we can multiply it by Avogadro's number to solve for the number of molecules. So I'm just going to go ahead and do that. So the number of molecules is equal to the moles times Avogadro's number. So I've got 0.265 moles times 6.02 times 10 to the 23 to give me 1.60 times 10 to the 22 molecules. And again, you'll notice that I've only got 3 significant digits in my answer there. That's because in the 2 numbers that I used to calculate that answer, the minimum number of significant digits was 3. So my answer is also going to have 3 significant digits. Okay, so I hope those are not too bad so far. This last one is basically the same thing, except it's going to require a slightly different little bit of groundwork. We're going to have to go around it backwards from the last one. So in the last one, we were given a mass from the start, so we had to use this formula. In this case, we're given a sample of tin, and we're told how many atoms we have. So the number of atoms is the capital N in this instance. So what do we know? Well, we know that we have 4.69 times 10 to the 28 atoms of tin based on that question. We also know the number of atoms per 1 mole with Avogadro's number, which is 6.02 times 10 to the 23. And we can also look at tin on the periodic table and find its molar mass, which is 118.69 grams per mole. So ultimately, the end goal is going to be to calculate mass, so we're going to look to find this lowercase m up right here in this formula. So that's what we're trying to find, m. So the first formula that I have 2 pieces of information for in this case is this one, because I know Avogadro's number, and I know the number of atoms of tin that I have, so I can solve for the number of moles. So the number of moles is equal to the atoms of tin divided by Avogadro's number. So 4.69 times 10 to the 28 atoms divided by 6.02 times 10 to the 23 atoms per mole. And once I do out that calculation, should have 3 significant digits, and I get 7.79 times 10 to the 4 moles. Now that I know my number of moles using this first formula, I can go back to the second formula and I can plug the number of moles in there and ultimately solve for mass. So if I rearrange this formula correctly, the mass is going to be equal to the number of moles multiplied by the molar mass. So I get 7.79 times 10 to the 4 moles times 118.69 grams per mole. And the fewest number of significant digits I have in that case is 7.79. So that's 3. So the answer works out to be 9.25 times 10 to the 6, which is quite a hefty amount, grams of tin. Alright, so I hope you guys found those problems okay. Again, they're not meant to be too much more complicated than the first ones that we've done. The only difference is these being 2 parts, so you have to use one formula in our tool chest to find the number of moles first, and then you take the number of moles you calculated using that first formula and plug it into the second formula to find your unknown. If you're having trouble figuring out which of the formulas in our tool chest we use first, always use the one in which you know 2 out of 3 variables. So remember too that because you have a periodic table, you always know molar mass when you're given the chemical formula of that particular compound, and you always know Avogadro's number, because that's 6.02 times 10 to the 23 per whatever you're trying to calculate in 1 mole. Alright, so some good practice questions for you guys to do now. Page 63, 28 through 33. Page 64, 34 through 37, as well as a number 15 table on page 76. Okay? So try to finish those during class. If you don't get them all done, have a look at those for homework, and we're going to go over those next class. Okay? Alright guys, hope that was clear. See you next week.